Okay, on this one, we're going to do this one to the 5th power. So to do it to the 5th power, we're going to need the row from Pascal's triangle, which coincidentally I have here on my note sheet. 1, 5, 10, 10, 5, 1. So let's go ahead and list that out. 1, 5, 10, 10, 5, 1. Okay, so there's our coefficients. Then, here we're going to have a slight problem because it's different than the previous one. This isn't just an x, this is a 2x. So instead of x to the power, this is actually going to be 2x to the power of 5. Your next term is going to be 2x to the power of 4. It's going to be 2x to the power of 3. 2x to the power of 2. 2x to the power of 1. And then no 2x's. Your next term is the 3y, or next value is the 3y. So here we have no 3y's. Here we're going to have 3y to the first. This is 3y to the second. This is 3y to the third. 3y to the fourth. And here this is 3y to the fifth. And then for the sign values, since everything's positive, these are all plus signs. So we fill these in with all positive signs. Okay. Now, unfortunately, this problem is going to have one additional step. On this problem, we're going to have to take and simplify each of these terms down. Okay, because there's arithmetic that can be done there. Okay. So let's first start with the variables. The variables are going to be extremely easy because the variables still follow the original pattern. This is x to the 5th, so it's x to the 5th. This is x to the 4th, y to the 1st. This is x to the 3rd, y squared. This is x squared, y to the 3rd. This is x to the 1st, y to the 4th. And then this is y to the 5th. So your variables there, quite easy. They still go 5, 4, 3, 2, 1, gone. 0, 1, 2, 3, 4, 5. Okay? And now we can also fill in the signs. This is plus, this is plus, this is plus, this is plus, and this is plus. Okay? But what we need here is what are the numbers out in front? So we're going to need to figure out those numbers. So get our calculator out and let's do some arithmetic. On this first one, we see that this is 2 to the 5th power. So this is 2 to the power of 5. So this is actually 32 times 1, which is just 32. Because this is 2x all raised to the 5th power, so you have 5 2's that are also being multiplied together, and then they're multiplied by the 1. Now the next one is 5 times 2 to the power of 4 times 3, or 3 to the 1st. So we multiply that out, and we get 240. So this is 240. The next one, we've got 10 times 2 to the power of 3 times 3 to the power of 2. Multiply that out, you get 720. So this is 720. On the next one, we've got 10 times 2 to the power of 2 times 3 to the power of 3. And we get 1080 as our coefficient. Okay. On the next one, we've got 5 times 2 to the 1st times 3 to the power of 4. And we've got 810. So this is 810. And the last one, we've got 3 to the power of 5, which is 243. So this is 243. So when you have a problem that has values in front of your x and your y, you are going to have to do a little bit of arithmetic in a second step in order to get to your final coefficient. But again, all your variables, very straightforward. So let's do one more. This one is to the 6th power. So let's refresh your memory on how we can generate Pascal's triangle to the 6th power. We know that the very first number is always going to be a 1. We know the second number is going to match the power, so that's got to be a 6. So now, let's go to Pascal's triangle using combinations. So we're going to have the power, which is 6. Go to math, go over to probability, go to option 3. Sorry, let me do that again. We're going to go, let me clear this out. We're going to enter the 6. We're going to go to math. We're going to go over to probability. We're going to go to option 3. Okay. And then we remember the 0 gets you the 1. The 1 gets you the 6. So now we need a 2. So now that's a 15. And then we hit second enter, change the 2 to a 3, and that's a 20. And then second enter, change the 3 to a 4, and we're back at a 15, which means the next number's got to be a 6, and the last number's got to be a 1. Okay? So there's our coefficients. Now, let's start throwing in our values. Okay? Well, this is going to be x to the 6. This is x to the 5, x to the 4, x to the 3, x to the 2, x to the 1, and then no x. Okay? For the y, oh look, we don't have a y this time. This time, it's just the whole number 5. So instead of writing y's, we're going to write 5's. So here, for this term, remember there would have been no y, so there's no 5. Here, this is going to be 5 to the 1st. This is going to be 5 to the 2nd. It's going to be 5 to the 3rd. It's going to be 5 to the 4th. It's going to be 5 to the 5th. And we're going to end with 5 to the 6th power. Remember, you always end at the power. Okay? And then on this one, because it's negative, remember the first term's positive. Here we're going to have 1 negative 5, which is negative. Here we have 2 negative 5s, which is positive. So then they alternate all the way through. Okay? And now we just have to worry about doing our arithmetic. Okay? So for our arithmetic here, our calculator off to the side here. Let's clear that out. So the first term, nothing really to do. This is just 1x to the 6th minus, here we've got 6 times 5 to the 1st. Well, that's easy. That's just 30. 6 times 5 is 30. X to the 5th power. Okay, now we're not going to have any y's here because we only have x terms. Now we got 15 times 5 squared, which is actually 25. So that's 375. So this is plus 375 x to the 4th. Okay. And this is minus, now this is 20 times 5 to the power of 3, which is 2,500. So this is 2,500 x to the 3rd power. Okay. Now the next term, we've got 15 times 5 to the power of 4. Well, this is plus 9,375 x squared. Okay. Your next term is 6 times 5 to the 5th. So this is 6 times 5 to the power of 5. Oops, sorry. This is 5 to the power of 5. And that gets you minus 18,750 x to the 1st. And then your last term is just 5 to the power of 6, which is positive 15,625. Okay? So it's a very long answer, but not much work. Okay? So that's multiplying out binomials using both Pascal's triangle and the binomial